This is Algebra 2 with trig. We're working on the review worksheet, 14.1 and 14.2. So we're going to look here at this equation. Our midline is at y equals 2. Our amplitude is a distance from the midline to the maximum or the midline to the minimum. So that's 1, 2, 3. The period is essentially the domain for one cycle. So we're starting at 0, we're going through that all the way out to here, so that's 4 pi. Now, let's talk about trying to write an equation for this. Well, the way that I've traced this out, this is looking like it's coming from the midline, finishing on the midline. So this is looking like a sine graph that is tipped upside down. Okay? So we could call this y equals -3 because the sine graph is not increasing first, it's actually decreasing. Now we got to think about the b value. Well, it might be kind of obvious, but let's do a little calculation. Period equals 2 pi divided by b. What I don't know is my b value. So my period, we said it was 4 pi. So if I multiply by b, and divide by 4 pi, that gets me to be b. Pi's cross off and I reduce. b equals a half. A half is going to make the graph go twice as far out. So this is half x, or theta, plus 2. That would be the typical equation that we would use for this. You have to know your amplitude. You have to know your reflection. You got to calculate a b value. You've got to identify if you feel that there's a translation or not, horizontally or a translation vertically. Using that as our cycle, that should be our equation. Here we have a midline at y equals 0. We have an amplitude from that midline to the highest point or to the lowest point. That's considered your amplitude. So that looks like it goes up 2. The period, since we're focusing on the y-axis, we could call this the graph that we're focusing on. Starting at 0 all the way out to 8 pi. That is stretching it 4 times more than usual. So you probably know what your b value is. But we can calculate our b value. If the period is 8 pi, and I multiply by b, and divide by the 8 pi, pi's are going to cross off and I reduce and get 1/4. So my equation is going to be y equals negative, because the graph I've associated with this curve looks like a cosine. It's starting at a minimum rather than starting at a maximum, so it's already upside down, so it's negative. 2 is my amplitude, so it looks like a cosine graph. B value is 1/4. It's not translated at all, so there you go. That's my equation. Let's try this one. We see a midline at 1. We have an amplitude of 1. We have a period. If I'm looking at my graph, right there, so we're going from negative pi to positive pi. That's a total of 2 pi. So my equation, the way that I have highlighted this one, this looks like a cosine graph that starts with a minimum, so it's already negative. Amplitude's 1, so I don't have to write 1. Cosine. It has the normal period, so I don't have to worry about that. But it does move to the left pi, so it's plus pi, and that would be in parentheses. And it is increased or translated up 1. So that looks like my equation. This looks like the line y equals 1, so the midline is y equals 1. Don't just write 1, write y equals 1. The amplitude is the distance till you get there. That you can write just the number 1, but it's not y equals 1, it's not x equals 1. You could almost say a equals 1. But a perhaps doesn't equal 1, so the amplitude's 1 though. The period, let's take a look at the period. Again, I'm focusing on the y-axis. So that's what I would suggest on right there, that graph. And that period is pi over 2. That seems to be a quarter of the normal size. So I probably already know what my B term is. But it would be good if you calculated it out. You know the period is pi over 2. So I'm going to multiply by B, multiply by 2, it's a quarter of the size, so the B value is a 4. So we could say that this is y equals negative cosine of x, of 4x, plus 1. Now, if you wanted to get crafty, that is my green. If you wanted to get interesting, you could focus on this as your graph. A little hard to see that. But that would be a sine graph that is not negative. It would still have the same amplitude, but it was translated to the right, and that would be pi over 2. Half of pi over 2 is pi over 4. Half of pi over 4, pi over 8. So if this was 1 over 8, this was 2 over 8, 3 over 8, and 4 over 8. That is reducing correctly. So this looks like this is pi over 8. So this moved over to the right, pi over 8. So remember, we use a positive, and it translated up 1. You could get away with that graph, but I feel most of you would have done the original green graph. But you can write all of these as a sine or a cosine. There's really an infinite number of equations that work. But I would focus on the y-axis and look at where the graph touches the y-axis and use that as the beginning of your graph. If that's a minimum value, you use that as a cosine. If it's on the midline, then you use it as a sine graph. Okay, let's come on down here. Write an equation that's translated. So we get y equals cosine pi over 4. We're moving to the left 2. So we say plus 2. And up 3. So we say plus 3. This is a sine graph. Amplitude of 5. Let's move to the right pi over 2, so it's always the opposite. You got to say minus. If it goes to the right, it's minus. If it goes to the left, it's plus. And it moved down, so we do call that down. Minus 4. All right. So we go from number 6 on this worksheet, and I've narrowed it down to number 13 for the graphs. So I've saved you some graphing. So whenever you do these, you first start thinking about the period of this graph. You probably already know what the answer is. If the b value is 1, then the period, which is calculated by 2 pi divided by b, that's 2 pi divided by 1, it's just 2 pi. And the increment is the period divided by 4, so it's 2 pi divided by 4, so that's called pi over 2. It's just the normal coordinates that we would use. So this is pi over 2, pi, 3 pi over 2, and 2 pi. If we were making a table, 0, pi over 2, pi, 3 pi over 2, 2 pi. The normal sine graph starts at 0, then 1, then 0, then -1, then 0. If we were to do y equals 2 sine of x, without the translation, we would multiply all of these values by 2. So I can come right over here to my graph I would be at 0, 0, pi over 2, 2. If that was 1, this is 2. 0, negative 2, and 0. Just like that. That's the graph y equals 2 sine of x. Now we're going to put in the pi and the 3. We do that by translating it to the right pi. That means every dot is going to move over 2 big steps. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. I probably should not have drawn that, because I can also translate it down 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Usually we don't draw both the translations individually, but I got carried away here, I guess. This is the graph y equals 2 sine of x minus pi, because it goes to the right pi, and it went down 3. So if that was 2 pi, that would be 5 pi over 2. This would be 3 pi. The domain is all real numbers. The range, negative 3, negative 4, negative 5, goes from negative 5 up to negative 1. We have no translation, or I'm sorry, reflection. We have a vertical stretch by factor of 2, and a translation right pi and down 3. Our amplitude is 2. We said the period was 2 pi. The midline is y equals negative 3. So I should put that in here. We have a maximum value at 1 and a minimum value at negative 5. This maximum value of the blue graph, that's the final graph, that was at negative 1. So the maximum was at negative 1. And the minimum was at negative 5. You could call it a point, really. That would probably be best. We have a maximum of 3 pi over 2, comma, negative 1. We have a minimum value at 5 pi over 2, comma, negative 5. That would be the point that exists at. Let's write it down here. Okay, we have a b value. You see here b value is pi over 4, so I need to do a period equals 2 pi divided by b. So that means that I'm going to do my 2 pi times the reciprocal. So my pi's cross off and I get 8. So 8 is how far, it's the period of the whole graph. To figure out what steps we're going to take, the increments are going to be 8 into 4 equal pieces, always divided by 4. So we're going to be 0, 2, 4, 6, and one more step makes 8. So we can come over here and say 0, 2, 4, 6, 8. If we're doing our sine graph, and this is just sine, it would be 0, 1, 0, negative 1, 0. If we're doing negative sine, now we could put our pi over 4 in front of that, I guess, since we have our x value in here. That would be 0, negative 1, 0, 1, and 0. So 0, negative 1, 0, positive 1, and 0. This is down 1, this is up 1. Now the reason why I made them so small and didn't stretch it farther for 1 is because I noticed I had to translate. I have to move all those points down 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. There it is. That would be y equals negative sine of pi over 4 x minus 4. That's going to have a midline at y equals negative 4. This would be negative 2, this would be negative 3, this is negative 4. This graph up here is just negative sine of pi over 4x. The domain actually goes on forever. It's all real numbers. The range of our green graph is going from negative 5 all the way up to negative 3. So our maximum point is when we're at 6, comma, our y value is negative 3. Our minimum point, our x value is 2, negative 5. Negative 5 is the minimum point. That happens when the x value is at 2. The amplitude, the distance from the midline, is 1. The period we already talked about was 8. And the midline is y equals negative 4. Okay, last one. So we're first going to look at this equation as negative 4 cosine of x. We're going to make it a little bit simpler. Just like that. So my b value is 1, so I know my period is going to be 2 pi. 2 pi divided by 1. And divide that by 4, that's pi over 2. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. It's the normal scale when the b value is 1. There's no value before the parentheses, no value before the x. There is a value before this x. So we had a b value there. So the normal cosine starts at 1, and then 0, then negative 1, then 0, then 1. that would be cosine of x. Now we're going to do negative 4 cosine of x. That's going to multiply all of those values by a negative 4. So let's take a look at what that means. We're stretching, so negative 4, 1, 2, 3, 4. We know our scale is going to be pi over 2, pi, 3 pi over 2, and 2 pi. So negative 4, 0, 1, 2, 3, 4. Okay, so this is indicating that the cosine is upside down. This has 2 minimum points, not 2 maximum points in one cycle. So that's why it's negative, is because it has 2 minimum points. So now we're going to translate it pi over 2 to the left, which is 1 step, and then 1 unit up. So we're going to, this would be negative pi over 2, so we're going to go 1 step to the left, which is pi over 2, and a unit up, 1 to the left and a unit up, 1 to the left and a unit up. And I like to do that in a different color. Try to roll it best you can. So this graph is y equals negative 4 cosine x plus means to the left, pi over 2, and then positive 1. My original graph down here was y equals negative cosine of x. That was 4. Negative 4. Okay, my domain is all real numbers because it actually continues on forever. The range is from negative 1, let's see, the blue graph. Here we haven't put in our midline. We need to do that. So now we can count from that. So we're at 1, 2, 3. This is 3 lines down. So we're starting at negative 3, and we're going all the way up to 1, 2, 3, 4, 5. A reflection. Reflected over x-axis. This does have a negative in front, so it has a reflection. The stretch. Vertical stretch by factor of 4. And translated pi over 2 to the left, left because it's plus pi over 2, and up 1. We have a maximum point at pi over 2 comma, we called that 5, and we had a minimum point at negative pi over 2 comma negative 3. You could also have said that it was 3 pi over 2 negative 3. Either one could have been your minimum. There's only one maximum inside that cycle. your amplitude from the midline 1, 2, 3, 4. That's always the absolute value of the A. And the midline is always your K value. Y equals 1. Good job, everybody.